Question 19. In a supermarket, the probability that John buys fruit is 0.7. In the same supermarket, the probability that John independently buys vegetables is 0.4. Work out the probability that John buys fruit, or buys vegetables, or buys both. Now, you don't need to put this into a tree diagram, but I think it will help. So I'm going to set it out in tree diagram form. So first of all, we'll look at the probability of buying fruit. And we'll use the F dash for not buying fruit. And then we'll do vegetables and V for vegetables and V dash for not buying vegetables. Then put the probabilities onto the branches. So if it's 0.7 for fruit, it'll be 0.3 for not buying fruit. Now, if buying veg is not affected by buying vegetables, that's why it says it's independent. So we're looking at 0.4 and 0.6. And we repeat again, it's just the same circumstances following not buying fruit. And then we can look at our three possibilities. So work out probably that John buys fruit, so it could be fruit with vegetables, that's buying both. And that will just be 0.7 times 0.4. So I'm not going to write out the multiplication, but I'm telling you that you multiply 0.7 times 0.4, which gives me 0.28. We then look at buying fruit but not buying vegetables, because we want John buys fruit or buys vegetables or buys both. Really, there is a fast way that I'll show you at the end of this, but I'll do it the tree diagram way first. So fruit not veg is going to be 0.7 times 0.6, 0.7 times 0.6, which is 0.42. And then we can finally look at buying vegetables. That's a condition here, buying vegetables without buying fruit. And that's going to give me no fruit but vegetables, and that's 0.3 times 0.4, 0.3 times 0.4, which gives me 0.12. Now I've got, if we look at my possibilities, I've got fruit, so I bought fruit here, or buying vegetables, so I bought vegetables here, or buying both, so I'll just go through that again. So I've got fruit here, so fruit with vegetables, fruit without vegetables. Buying vegetables, so buying vegetables without fruit, or buying vegetables with fruit, or buying both, so buying both here. So you simply add them all up together, and you'll find that comes to 0.82. Now, that is rather a long way of doing this, but it might be the most familiar way. The clever way is to say that if we're buying fruit or buying vegetables or buying both, then that will be 1 minus not buying either. 1 minus not buying fruit and not buying vegetables. So not buying both is not buying vegetables and not buying fruit and not buying vegetables. 0.3 times 0.6, so it'll be 1 minus 0.3 times 0.6, which is 1 minus 0.18, which equals 0.82. Now, you might have said, why didn't you just do it that way in the first place? It is the fast way, and they haven't drawn a tree diagram, but many probability questions that involve two events are solved with tree diagrams. I think it will help you to see how it can be done with the tree diagram, but also know how it can be done quickly. So that's your answer.